Hello and welcome to another session of CXC multiple choice item in which we'll be looking at some past questions based on computation. I'm Hirulal Baljor. Do enjoy. This question reads, the coefficient of x in the expansion x plus 3 into x minus 1 is. They're looking for the coefficient of x. If we were to expand the brackets here, we would have seen using the first value in the first bracket distributive throughout the other bracket, it would have been x times x plus, and y plus, this value is positive, x times minus 1. So this accounts for our first x value. Then we go distribute throughout by positive 3, which would have given us plus 3 times x plus 3 times x plus 3 times minus 1. In simplifying the expansion, we would have had x by x gave us x squared, x by minus 1 gave us minus 1x, plus 3 times x gave us 3x, plus 3 times minus 1 gave us minus 3. And further simplifying, we would have had x squared is the only value that exists by itself. So we have an x squared term. A minus x plus 3x, the coefficient minus 1 plus 3 gave us a positive 2x minus 3. Now when we finish expanding x plus 3 into x minus 1, we would have had this equivalence here as being x squared plus 2x minus 3. They're asking us for the coefficient of the x term. The coefficient is the value in front of the variable. The coefficient of the x squared term is 1. The coefficient of the x term, please note I'm using the symbol in front of the coefficient. The coefficient there of the x term is positive 2. So we're asked for the coefficient of the x term and not the x squared term. So our solution there is C, which is positive 2. In a school, the ratio of the number of pupils to the number of teachers is 20 to 1. If the number of pupils is 840, how many teachers are there? So when we look at the ratio here, they're telling us in this school, for every 20 pupils, there is one teacher. Every 20 pupils, one teacher. Now, if there's 840 pupils, how many teachers do exist in the school? Dividing the number of students to the number of teachers ratio, we would have had 840 divided by 20 give us this value x, which is the number of teachers. So the ratio of pupils to total teachers, which would have been 20 to 1, is 42 teachers. So our solution here is B. Written in scientific notation, 0.045 multiplied by 10 to the minus 3 equals. Now, here we have a number that is written in scientific notation partially. What do I mean by partially? It's already written in some powers of 10. However, it's not in the total or the generic form of scientific notation. What do I mean by generic form of scientific notation? The scientific notation principle means we need to have a number that has value in front of the numerals. So in this problem, we have numbers in front which doesn't have a value, which is 0.0. Hence, we need to have a number that has a value. So what we need to do is to shift the point to let the number have a value. So it would have been 4.5 times 10 to the minus 3, but we have shift 2 places. And because it's a decimal, we need to add another 2 points of shifting. And that's how we have this minus 2, because the number of places that we shift is 1, 2, 2 places. And when we're moving from the left to the right, the value is negative. Additionally, we can use that concept. So our solution for this question here would have been 4.5 times 10 to the minus 5, written in scientific notation, which would have been B. What percent of 30 is 6? Now, this question is asking us, out of 30, what percent is 6? So in representing 6 out of 30 as a percentage, it would have been 6 upon 30 times 100. And when we compute this, 6 1s, 6 5s, 5 1s, 5, 20. So 6 represents a percent of 20, which is C. The number 301 can be written as, and here we have a question that we can subdivide into powers of 10. Distributively, the number can be divided. Now, we're looking at a number 301. As we read it here, we could say that this number is 300 plus 1. We could also say that this number is 3 times 100 plus 1. We can also say that this number is 3 times 10 squared plus 1. 10 squared is the same as 100. So, our solution for this question when we look there would have been A, 3 times 10 squared plus 1, which would have been equal to 301. What is the least number of plums that can be shared equally among 6, 9, or 12 children? The least number of plums would have been to find the lowest common multiple among 6, 9, or 12 to see which is that number that can go among the 3 of them. So, to find the LCM of 6, 9, and 12, you could go by dividing by 2 first, continuously dividing by 2 until we cannot divide, until the numbers cannot be divided any further by 2. Then we go to the next value of 3 and dividing by 3 until the numbers arrive at 1. Hence, the lowest common multiple among the 3 of them would have been 3 times 3 times 2 times 2, which would have been 3 times 3, 9, 9 2s 18, 18 2s 36. Our solution for this question is B, 36, the least number of plums that can be shared among 6, 9, or 12 children. If P sweets cost Q cents, then the cost of 1 sweet is P sweets. That's the total amount of sweets. P sweets cost Q cents. Therefore, the cost of one sweet would have been, we take the number of sweet, which would have been P, divided by the cost, which is Q, give us the cost of one sweet. So our solution for this question is P divided by Q cents, which is C. When 8 is subtracted from a certain number and the result is multiplied by 3, the answer is 21. What is the original number? Here we have this question written as, we have a certain number, n, and we subtract 8 from it. And the result of this number, we multiply it by 3, and the result of all of this would have been 21. They're asking us for what is this original number. In simplifying this, we distribute throughout the bracket by 3. So it would have been 3 times n plus 3 times minus 8 equals 21. 3 times n gave us 3n. 3 times minus 8 gave us minus 24, should equal to 21. Balancing the equation, 3n minus 24 plus 24 equals 21 plus 24. Whatever we do on one side of the bracket, we should do on the opposite side to maintain our balance, where 3n should equal to 21 plus 24. 3n give us 45, where n is 45 upon 3. N is equal to 15. So our solution for this question is D. Our original number is 15. Given that 3 operation 6 equal 12 and 2 operation 5 equal 9, then A operation B may be defined as. And in this question, we were not given what is the operation. We are asked to find the operation. However, they give us some clues to tell us that when 3 operation 6, the result is 12. When 2 operation 5, the result is 9. So what we need to do is to use method of elimination and go through the solution to see which one of them will satisfy. When 3 operation 6, the solution is 12, and when 2 operation 5, the solution is 9. If we were to choose the first solution there, A, 4 of B minus A, and substitute these values, we will see 4 of B, and mind you, B would have been whichever one we are using, either one of them, A equals 3 and B equals 6. In substituting here, we would see 4 of 6 minus 3, which would have been 4 of 6 minus 3, which is 3, which would have been 12. It did satisfy our first binary operation. However, in the second operation, if we were to use the same values and substitute them, 4 of 5 minus 2. So in solving 4 of 5 minus 2, which should have been 4 of 3, which gives us 12. Hence, this did not satisfy our second operation of 2. Operation 5 should equal to 9. Hence, A is not correct. Using B, and by the method of elimination, A squared minus B, substituting those values again, we would have had A squared being 3 squared minus 6, which is 3 square is 9 minus 6, which is equal to 3. Hence, already we see that B is not one of our solution by method of elimination. When we look at C, 6A minus B, by substituting 6 of 3 minus 6, this would give us 18 minus 6, which is equal to 12. It satisfies our first equation. Let us see if it satisfies our second equation. Then we will know what to eliminate or not to eliminate. 6 of 2 minus 5, which should have been 12 minus 5, is equal to 7. Therefore, C did not satisfy our equation. Therefore, C is also incorrect. Continuing by substitution, 2 of 3 plus 6 should have been 6 plus 6 give us 12. This satisfies our first equation. Let us see if it will satisfy our second equation. It would have been 2 of 2 plus 5, just 4 plus 5, which give us 9. Hence, the operation which satisfy 3 operation 6 should equal to 12 and 2 operation 5, which is equal to 9, would have been 2 of A plus B, which would have been D, our solution. 10,800 seconds expressed in hours. Now, we would have known that 60 seconds equal 1 minute and 60 minutes equal 1 hour. Therefore, 60 by 60 would have given us 3,600 seconds. So 1 hour is equal to 3,600 seconds. So if you were to represent 10,800 seconds in hours, we divide this by 3,600. In computation here, we would have had 3 hours. So 10,800 seconds would have been 3 hours, which is A, our solution. When 5 is added to a certain number, the result is multiplied by 3. The final answer is 27. What is the original number? They're telling us a number plus 5, and this result, when we multiply it by 3, the solution is 27. What is this number? Distributively removing the bracket by 3, this would have given us 3 times n plus and y plus. This plus comes from this positive 3 times 5 should equal to 27. This would have given us 3 by n is 3n. 3 by 5, 15 should equal to 27. Balancing our equations, 3n plus 15 minus 15 should equal to 27 minus 15. Positive 15 go out with negative 15. 3n would have been 12, where n would have been 12 upon 3, n would have been 4. So the solution for this question is A, n equal 4. If x equals minus 2, y equal 3, and t is equal to 2, then they're asking us to substitute. What would have been x divided by y raised to the t power? In substituting, x being minus 2, y being 3, raised to the second power would have given us, in further computation, minus 2 square divided by 3 square. So minus 2 square would have been minus 2 times minus 2. 3 square would have been 3 times 3. Multiplying minus 2 times minus 2, this gives us a positive 4. 3 multiplied by 3 gives us 9. Hence our solution for this question is 4.9, which is B. This question reads 3x squared multiplied by 2x cubed equals. Coefficients we multiply first. So this would have been 3 times 2. Then the laws of indices says when we are multiplying base quantities which are the same, and there we have an x and an x, base quantities which are the same, we add their power. So this would have been x of 2 plus 3. And for the computation, we would have had 3 times 2 give us 6. X 2 plus 3 give us 5. So our solution for this question is A, 6x raised to the 5th power. If P equals 8, 6, 7, 5, and Q equals 1, 2, 3, 4, 12, 3, 4, 1, 13, 14, 1, 2, what is the order of matrix Q? Now we have two matrices here. We have matrix P, 8, 6, 7, 5, and we have matrix Q being 1, 2, 3, 4, 12, 3, 4, 1, 13, 14, 1, 2. They're asking us for the order of matrix Q. So we're looking at Q, matrix Q. Now the order of a matrix is the number of rows times the number of columns. Rows are horizontally represented. So in matrix Q, we have row 1, row 2, row 3. So how many rows we have in this question? We have 3 rows. How many columns we have in this question? Columns are the vertical standing orders, which would have been C1, C2, C3, C4. So we have how many columns here? We have 4 columns. So the order of this matrix would have been 3 by 4. That's the order of matrix Q, 3 by 4, which is A, our solution. If 30% of a number is 45, what is 4/5 of the number? Now 30% of the number is 45. All we need to do is to find the 100%, which would have given us the number. So 30%, if we were to find the 100%, it would have been 100 upon 30 times 45, which would have given us the whole number, or the number in terms of 100%. In finding this number here, 3 ones, 3, 15. The original number is 150. However, we do not want the original number. We want 4/5 of the number. Now 4/5 of 150, which is our original number, would have been 120. So 4/5 of that number would have been 120, which is B, our solution. The next number in sequence, 1, 6, 13, 22, 33 is, here we have a sequence and pattern question, and the sequence reads 1, 6, 13, 22, 33. We want to know what is this next number. To find this next number, we need to see what is happening with 1 to arrive at 6. And we have seen if we take 1 and we add 5, we get this number 6. We need to look to see what happened with 6 to 13. If we take 6 and we add 7, we will get this number 13. What number, or what do we do with 13 to arrive at 22? 13 plus 9 gave us 22. What number do we use with 22 to give us 33? So we would have seen in the pattern, we start with an odd number and we're incrementing it by 2. What do I mean by incrementing it by 2? We would have seen the first number that we add to 1 that gave us 6 would have been 5. The next number would have been 7, which is an odd number incremented by 2 from 5. 5 plus 2 gave us that 7. 5 plus 2 gave us that 7, which is an odd number. 7 plus 2 gave us the next number of 9, which is odd. Next number would have been 11, which is 9 plus 2 incremented there by that 2. Therefore, the number that we are looking for would have been 33 plus the incremented value here of 2 would have been 13, which is also odd, to give us the next number in the sequence being 46, which is our solution C. By the distributive law, 49 multiplied by 17 plus 49 multiplied by 3 equals, here we have seen 49 is the common factor among the two quantities, 49 times 17 plus 49 times 3. So if we're going to take out that number there, which is the distributive quantity throughout the operators there, we would have seen what remains is 17 and this 3 value. The and comes in where this plus sign comes to. So this would have been 49 times 20. How do we get 20? This 20 is found by the 17 plus 3, the two remaining values. So our solution for this question would have been D, 49 times 20. A test was marked out of 80. A boy scored 60% of the marks on the test. How many marks did he score? Now this test was marked out of 80, but this boy got only 60% of the marks. So what is 60% of 80? It would have been 60 upon 100 times 80. This boy would have gotten 48 out of 80. So the solution for this question is B. 3.3 times 2.5 plus 5.7 times 2.5 is equal to. Now, when we look at this question here, 3.3 multiplied by 2.5 plus 5.7 multiplied by 2.5, we would have seen a quantity being distributive throughout the operators there. And that quantity would have been 2.5. So this would have been the same as 2.5 multiplied by the remaining quantities, we sum them. So this would have been 3.3 plus 5.7. For the computation, this would have been 2.5 multiplied by 9, which would have given us 22.5 being our solution. So the answer for this question would have been D. Using the distributive law, P times Q minus P times R is simplified to be Now, here we have a distributive property in the form of subtraction, not multiplication. We would have seen the value that is distributive throughout is P. So by distributive law, this is the same as P into Q. Instead of addition, we have the subtraction, subtract R. So our solution for this question is D by distributive law.